Talk on why databases don't cloud well and what to do about it. If you're not a database person, databases can be very confusing. If you need to get a hold of me, it's my email address at Stoker on Twitter. And if you don't know Percona, we're the first booth as you walk into the left in the vendor area. We're specialists in open source databases, so if you have questions, please talk to us. There's two types of people in the world, database people like me and Jan here, and the rest of you who don't have as fulfilling and happy lives as we do. Databases are confusing, they're messy, they're the toddlers of the software world. They're demanding, they need observation, and if you let them run wild, they will consume everything and all your time and your sanity. So, audience participation time. If you go out to Wikipedia and you look up cloud computing, what's the first thing you find? I mean, you don't go out to Wikipedia and look up cloud computing all the time? Okay, the first answer is a horse that, next time your boss says you want to invest heavily in cloud computing, you can get a live foal for $5,000. So, beautiful horse, but probably not what your boss is expecting. So, cloud computing, second entry on Wikipedia. A little more kind of in mode of what we're doing here. Basically, distill it down to online, on-demand availability of computer system resources, especially data storage and computing power. I will argue that most of the cloud work that we see today is more computing power and less cloud storage, but it's there. The basic idea is you have everything encapsulated in some sort of container using some sort of messaging queue to have everything go back and forth. Simple, right? We can all handle that. The only trouble is the way it's implemented with containers and Kubernetes gets a little fussy when you're coming back from the database side. So what goes on is you expect Kubernetes to be a nice little bouncy child, and you end up having that little demon child there trying to eat your face off. So when I say databases don't cloud well, I should probably change that to from cloud to container well. Databases are not supposed to be ephemeral. They're supposed to be around for a long time. They're not designed to be stateless. So the big answers are use persistent storage, use a DBAS. By the way, we have a new DBAS. If you want to take a look at it, we can show it to you at our booth. And use a really good operator and persistent storage. So databases. A lot of my career has been arguing with product managers, especially agile programming managers, that databases don't work the way they expect or the way they want. Databases came about in the 1970s. They're the only technology from the 70s still popularly used. SQL was the first programming language to be able to go out and give me multiple records. Every other programming language before that, you got one record and it kept reading until end of file marker came through. Designed to be a permanent store. For relational databases, you broke down components to the various groupings. You'd have customer information in one table. You'd have product information in another table, shipping information in another table. So you broke it up logically, which was great because you kind of partitioned your data into logical groups. Databases are very complex. I know folks who write operating systems who will not touch databases because they think the coding is just too crazy. And the big thing for most businesses is they support transactions. Transactions are a nasty thing to try to write. Anyone here who's gone through the Mongo wars and gone to try to make that transactional can testify to that. So, what are the issues with databases? Well, first thing, permanence. If you want your data to stick around. In the ephemeral container world, you spin it up, it doesn't work, it goes away. You don't want your data going away. Another problem with databases, especially in you're fighting a Kubernetes environment, is databases need a while to warm up. You have to seed caches. The thing has to build stuff out. The other thing is the query is answered by something called an optimizer. The optimizer goes out there and it has historical information of where the data is and how to get that data the least cost ways. Cost is usually measured in disk reads, which is changing a little bit in the database world. If that information is wrong, your query is wrong. Now imagine you're in an environment where you're firing up 8 different copies of the database. People are writing here, they're writing there, they're writing there, and you want the most consistent, fastest, latest information. And that query planner has to go out to all these other places and assemble that all together. It becomes a real nightmare. By the way, as the data moves and churns, your query plan will change. Alt data statistics lead to bad query plans, and improper indexing of rows can swell execution times. Making new copies of instances is not instantaneous. No matter how quickly your boss tells you he wants that 1.5 terabyte data copied and up on another zone, it don't work that way. Also, if you go into sharding and replication, you need a very reliable infrastructure. There's nothing like a flaky link to drive a DBA or SRE up the wall these days. The analogy to use is think of your database as a lorry. It's going down the M1 or the M4 at high speed. It takes a while to get up to speed from zero. It's designed for heavy loads. It handles it very easily, designed to take care of it. But it takes a while to get up to speed. Also, you need to have precautions slowing down. And going out and changing the metadata around that truck while it's on running is very, very nasty and can be disastrous. You also hear the terms high availability or fault tolerance. Either way, this is very expensive. High availability is a continuous operation of database systems, but it's not 100% uptime. The people who are promising you 99.999% uptime, that's still like 5 minutes downtime a month, which for some of you is no problem. I know folks who are saying, oh my God, I've planned 500 milliseconds downtime a month. What's wrong with your database, folks? So high availability, you want no single point of failure. You're going to build in a lot of redundancy. You're going to do a lot of load balancing, failure detection, and failover. All those are pronounced expensive. Now, if you really, really have a lot of money and your bosses are demanding no downtime, you're going to have what I call redundant redundants. You're going to have backup systems to backup systems, backup systems. You're going to have alternative environments, and it's expensive. You're going to have to go out and plan what happens if your main database is not writable. How do you store that information? How do you get it back in there? How do you architect that? And how do you keep the customers unaware of all that? Now, for those of you who are from the MySQL world, this is MySQL's InnoDB cluster. You have 3 nodes. One that handles reads and writes, 2 others that handle write only. When they go to commit a new piece of information, a new row to the table, they all coordinate. They all get the information, say, okay, I've got this information. Okay, we're all going to go write it at the same time. That's a 2-phase commit. This is a great way to keep your data from getting lost, but all that 2-phase commit is extra time. That's extra overhead. So when you look at the numbers that your hardware should be able to do, and you look at what actually goes through, you got to plan for this overhead in there. Now, the other thing about this is great, and it does scale. And as you can see here, you have one primary cluster in the middle, 2 replica clusters, but you still have a 2-phase commit. And as you send stuff back and forth through the various clusters, there's timing delays, there's also sync delays, and more commits. So as you go from this to this, your database problems expand exponentially. Now the good news is this is a proven technology. It's been around for a while, and it works very well. So if you're running MySQL, one thing I highly recommend is save your cache at shutdown time, and then make sure that you enable it that when you start up that cache is read in. That seeds the caches so that you don't have to worry about the system having to relearn where all the data is, so it can actually do fast queries upon startup. Also in the MySQL world, there's a thing called the clone plugin. This basically does a wire speed transfer from a donor to the replica system to get your data up. So here it's much faster than a lot of ways of restoring stuff, like from a backup. However, you are limited by your wire speed. So if your wire speed is from one part of the world to the other part of the world, got to plan for that. Also, sharding. This is something that tends to drive folks up the wall. Imagine we've sharded our data into a blue group and a yellow group, and we keep everything in the yellow group on one server and everything in the blue group on another server. This is a great way to speed things up. The optimizer knows that anything that has a value between 22 and 99 is going to be in the blue group. Now, the trouble is, this can get messy to maintain and operate. It works very well, but if you're trying to do quick queries, like you're looking for something between the value of 7 and 16, very easy to do. Now, if you're trying to do all the data between 7 and 99, it has to read both shards, so you don't gain any advantage by having a smaller group to search through. Now, as the complexity grows for databases, the harder it is to keep track of all the pieces. What I like to recommend to folks, this is a free open source product from my company, Perconas. It's called Percona Monitoring Management. It monitors Mongo, MySQL, MariaDB, Postgres, underlying Linux boxes. It's a single pane of glass where you can go out there and see what things are doing. You can burrow down, see what your cache hit rates are. You can actually do query exploration to find out what the query is actually doing, and it's great. Once you get past one database, it gets hard to monitor what goes on. This is a great way to be able to look at stuff. The other great thing about something like this is it gives you historical information. So if you come in on Monday morning at 8 o'clock and your boss says, hey, I was trying to use the system last night, what happened? You can go back and dig through the historical information to find out what's going on. Oops, by the way, this is free, open source. So some best practices, but before we do that, more audience participation. 2 queries. The only difference is the one on the right has a limit of 10. And the question is, if you're looking for all the customer purchases sorted in descending order versus all the customer purchases sorted by descending order, but you only want the top 10, which query runs faster? Okay, I have some people pointing at the one on the right. A couple of people pointing on the left. Well, the actual query itself runs in the same amount of time. You're just kind of chopping off the results as you send it to the server, so it might be fractionally smaller. Now, what happens is your boss will come back and say, I want you to go through the last 20 years of customer sales information and tell me, who the top 5 customers are. And you run off this and it goes, hey, I'm only looking for 5 records. Why are you searching through all of them? Just give me the 5 best ones. So you need some political skills there to be able to tell your boss that anytime you do an aggregate like that, it doesn't matter how many you're asking for, it's still going to run at the same time. So, big hint, be reasonable about your queries. As I mentioned, any aggregate work takes clock time. Index your data where it makes sense, and make sure you maintain those indexes. I see a lot of folks treating their normal databases like a data lake, and it ends up being a data swamp. Also, if you have folks who do ad hoc queries during the middle of the day, ask them if that makes sense. Maybe you point them over to a read-only replica. I've seen lots of businesses that suddenly at 3 o'clock on Friday afternoon where they're trying to close out the quarter for the financials, and someone goes out there and starts doing marketing analysis on the data and things start crawling. Also, schema changes are expensive. They're slow. In the MySQL world, if you're copying a table, if you're going to change a table, it makes a copy. So if you have a 2 terabyte table and you're making a copy of it, you suddenly have a 4 terabyte table where half the stuff's being shoved through the other half. Chews up disk space and computation speed. If you need to do it, do it. Plan it around lull times. Unfortunately, in the agile world, the idea that a schema change is instantaneous doesn't quite work. Housekeeping. You have to go through your databases and do things like remove redundant indexes. Indexes take up memory and disk space. And if you have a redundant one, that means every time you insert a record, it gets inserted in both places. So if you have any redundancy, that slows you down. Also check periodically for popular queries running without indexes. Indexes really speed things up. If you have indexes, don't have indexes, that will hurt you. Also, double check your query plans from time to time. As your data grows and changes, sometimes your query plan becomes less and less effective. You might need to figure out how you're going to reindex or partition the data or do something else. And the bottom line there is the one that I think all DBAs should have tattooed on the forehead of every developer. Have great backups. If you don't have a great backup and you lose your data, it's gone forever. I've seen a lot of companies get into trouble because, for instance, a company near my house 2 years ago was asked by their legal department, hey, we need a copy of your database from August 17th of 2 years ago. Can you do that? Well, we really don't have it. And the legal says, well, our data retention policy says we keep everything for 5 years. Why don't you have it? Run analyze on your table. This is a low impact way to update the statistics for the optimizer. In MySQL, I think it reads 10% of the table. In Postgres, it's somewhere between 5 and 7%. But the good news is your database has fresh index statistics out there for the optimizer to use. Transactions. Teach your programmers to keep transactions as short as possible. I used to make a good living by going out and finding out that a developer had decided, okay, I'm going to do a transaction. First thing I do is I lock all the tables, go off and do some computations, check some other stuff, and then come back and do the actual transaction. Keep the transaction short and punchy. Don't draw it out. Once again, monitor. You can't do everything 7/24, 365 by yourself. Use something like PMM, which again is free. This is a great tool for helping you observe what's going on. Also helps with capacity planning. And with that, I think I made up the time that we lost earlier. By the way, if you want a copy of the slides out there on speaker deck, I know the organizers have copies, and please drop by our booth. We're having a VIP session down here at 3, I believe it is, later. And we'll be around for the booth crawl. Any questions, comments, concerns? Or are you all hungry for lunch and you just want to charge off right now? Okay, well, if you have any questions, let me know. I'll be at our booth, and thank you all for coming out.